In this video, we'll discuss the circuit for vibration actuator without the button. We are going to make 7 of these vibration actuators. Then we'll discuss the circuit for vibration actuator with the button. We are just going to make one of these vibration actuators. The one we have with the button is actually a control for the entire system. So when the button is on, the vibration on every single motor is on, but if the button is off, none of the motors will vibrate. So the user has the control on when to turn on and off the vibration. Next, we look into 3D printing the boxes and lids for the actuators with and without the button. After that, we'll just look into enabling the fast charging on Adafruit micro LiPo charger. And then we look into certain steps like desoldering the cores or photons and soldering everything and putting everything into the box we printed. I just wanted to give a tip that you can buy photons or particle photons without the headers, so that will save you some effort of desoldering. So let's look into this. This is a circuit diagram for vibration actuator without the button using a particle core. So the diagram is pretty simple. The vibration motor is connected between the pin A0 and ground. So the positive of the vibration motor goes to the pin A0 of the particle core, and the negative of the vibration motor will go to the ground pin of the particle core. Next, the Adafruit micro LiPo charger is connected to the particle core. So the ground pin on the LiPo charger will be connected to the ground of the particle core, and the battery pin or the BAT pin will be connected to the VIN of the particle core. Then if you connect the lithium ion battery on the battery port on the LiPo charger, you can power the core. Now let's look into the same vibration actuator without the button but using a particle photon. Here everything will be similar. The only thing that is different here is instead of putting the vibration motors positive to A0, you're putting it on pin A4. So we are doing this because pin A0 on a particle photon is not a PWM pin and A4 is a PWM pin. So we are using the pin A4. Next, we'll look into making a vibration actuator with a button, and this time with a particle core. So the rest of the circuit will be similar. The vibration motor goes between A0 and ground. We'll add a latching switch in the button vibration actuator. So what we are doing here is the positive of the latching switch will go to the 3v3 pin, the negative will go to the ground pin, and the signal pin will go to the D6 pin. So D6 is more important to remember. Next, if you're making one with particle photon, everything will be same, and the signal pin will go to the D6 pin of the particle photon, the negative will go to the ground, and the positive will go to the 3v3 pin. So the only difference between photon and core is that the vibration motor's positive will go to A0, and in a photon it's going to be pin A4. Next, you can use the STL files and 3D models provided with the code to print the boxes and lids for the vibration actuators. So this one would be the vibration actuator box for the vibration actuator without the button. You can see there are only 2 holes on this one. The other one will be the vibration actuator with the button, and so you can see the middle in the middle there is a hole for the button to come out. So there are 2 different files and you can use whichever you want. And then there will be a file for the lid, so you can print the vibration actuator lid, and the lid will be the same for both the boxes. To speed up the charging of the vibration actuators, we are going to put a dot of solder on the solder jumper of the micro LiPo charger. By default, the charger is configured to charge with 100 milliamps, but when you put a drop of solder on the solder jumper, it charges with 500 milliamps. So it speeds up the charging of the actuators. If you put the particle cores or particle photons with the header pins on them, you can desolder the header pin so that you can get the microcontroller only and you can fit it nicely in the 3D printed boxes. Just a tip that you can buy particle photons on their website without the header pins. Once you have desoldered all the particle cores or photons, what you can do is you can solder all the components together as shown in the circuit diagrams discussed before, and then you can have the innards of the vibration actuators ready. Now that our circuits are ready, we can put them in the boxes we 3D printed for the actuators. So what we'll do is we'll take the particle core or photon or the microcontroller first, and then we'll press it into the box for the actuator. What we are going to be careful about is the buttons on the particle core or photon should face down, and the USB, the micro USB port on the particle core should be facing the opening on the box, which is on the side. Next, we'll go for the motor. So we'll try to press in the motor on the slot provided on the side. Let me do it correctly. And we'll just press the motor. It fits very snugly, so you can just press the motor in the side slot, and then finally we'll put the Adafruit micro LiPo charger in place. And here as well, the micro USB port on the charger should come out on the side of the box. So there is an opening for two micro USB port, one for the charger and one for the particle core. Finally, we'll just plug in the battery on the micro LiPo charger. So we take the battery, and on the port where we can plug in the battery, we'll just push the battery plug in, and that's it. We'll just layer the battery on top of every other component inside the box besides the motor, and we'll take the lid and we'll put the lid on it, and that's it. Our vibration actuator without the button is ready. If you're making the vibration actuator with the button, the only thing you do differently is put the button in the slot for the button. So the button should come out of the opening, and then the body of the button fits snugly into the slot provided. And finally, we'll have our vibration actuator with the button. Thank you very much for watching.